Good evening. Welcome to our meeting of Baton Rouge Astronomical Society. It's our June meeting. Tonight, our talk is going to be on the Tunguska event in recognition of Asteroid Day, which is coming up.
Can't hear you.
Okay.
Same.
Louder then. Tonight's talk is going to be on the Tunguska event because it was always been recorded there for the Asteroid Day, which is coming up shortly for us here. So I'm going to be giving the talk tonight on the Tunguska event. Okay? So, what happened here, let me see if I can get this slide to work right. What seems like it's one other line.
Here, hand me that thing. Let me see if I can get this guy up. There you go. If you turn it on, that helps.
I did.
Okay. Well, the green thing on the side tells it's on versus the red is off. All right.
I'll try it again.
Let's see. See if that clicks around.
There we go. Finally got it right there. Okay, well, the ghost event happened at 7:17 a.m. on June 30th, 1908. It was near the Stony Tunguska River in the eastern Siberian taiga area in the Nis, I'm not sure how to pronounce that, the Nis government of Siberia. This was under Tsarist Russia. The explosion, which they know is an explosion, they don't know yet what that was, find over 2,000 square kilometers, which is 700 square miles of forest. It's estimated 8 million trees were knocked down by this blast. And the meteoroid, which they assumed it was, estimated to be 200 to 690 foot across. Now, they have talked about that, they've done some research in on it. They're saying right now that one of the more wilder theories is that it was an asteroid that grazed the Earth, just came through our atmosphere, did not hit anything on it, just came through our asteroid. And all the scientific stuff that they calculated out on it, it fits about half of the parameters, but about half of it does not fit. So they pretty much can say it was not an asteroid. They think it was an actual meteorite or boloid that did an air explosion. Now here's an example of some of the flattened trees. They didn't do anything. The first scientific investigation was almost 20 years before anyone went out there.
Still can't hear you too well.
So these are pictures from 1927.
Is the audio still dead?
Yeah, you can barely make out what he's saying.
Okay.
Not hearing anything?
I'm sorry.
It's just a little bit quiet. I have it cranked.
All right. I've got the selection of a couple of different microphones here.
What's up, y'all?
Yeah, what's going on?
I heard that.
Oh, yeah, that's me. That's Thomas.
No sound HRPO.
A lot of, there's people there who were there within 20 to 50 miles of it, and some of them 100 miles or more away. And part of what they were talking about, some of them said that they saw a bright flashing light in the sky, which lasted for up to a minute, and then something like a sonic boom, but much worse. There we go. This is one of the eyewitness accounts. Eyewitness says, me and my brother Chekarin were sleeping in our hut by the river. We were shoved by it. We could hear whistling and felt a strong wind. I got shoved again so hard I fell into the fire. This is the air pressure shoving, I guess, so the blast pressure. We could hear trees falling and we wanted to run out of the hut, but then the thunder struck. The earth began to move and rock. The wind hit our hut and knocked it over. My head was in the clear from the demolished hut. Then I saw trees falling, branches were on fire. It became mighty bright as if there were a second sun. Immediately there was a loud thunderclap. After my brother and I got out from under the remains of our hut, we saw that above, but in a different place, there was another flash, and loud thunder came. Wind came again, knocked that block there, knocked us off our feet and struck the fallen trees. We looked at the fallen trees, watched the treetops get snapped off, watched the fires. Suddenly my brother yelled, "Look up," and pointed. I looked up there and saw another flash, and it made another thunder. If I remember right, this was about 25 miles from the epicenter of it. If I remember correctly on this one. Okay, it's still not advancing on me. But there's different eyewitness accounts. There was injuries, I think of broken arms from people being knocked down and things being thrown into it. Yeah, I think that there was actually one death from a nomadic tribe. They had one death recorded from it.
Where do you want to be, John?
Huh?
You can't work. What slide do you want?
Next one after the next one. Okay. Now this is from the newspaper account on July 2nd, about a week afterwards. It says on the morning of 17th of July, June around 900, we observed in the northwest, rather high above the horizon, some strangely bright, impossible to look at it so bright, bluish white heavenly body, which for 10 minutes moved downwards. The body appeared as a pipe. The sky was cloudless, only a small dark cloud was observed in the general direction of the bright body. It was very hot and dry. The body neared the ground of the forest. The bright body seemed to smudge and then turned into a giant pillar of black smoke, and a loud knocking, which was not thunder and knocking sound, was heard as if large stones were falling or artillery was fired. All the buildings shook. This is accounted by the peasants in the north of Karolinsky village, about 400 kilometers southeast of the ground zero. So just they want to cut off everything.
There are blank slides in here,
Shouldn't be.
but there are.
Okay. Okay, this is what the present day trees look like from the blast. Okay. Okay. The air blast, as they say that they think that the body, whatever it was, the air blast in the air there, says it's generally equivalent to an air blast of an asteroid, thought to disintegrate at an altitude of 3 to 6 miles high. Earlier estimates of the air blast estimated from 10 to 30 megatons, TNT. The modern calculation says 3 to 5. But the Nagasaki bomb was around 20 kilotons versus the megatons that they were estimating at that. And it says the last shock wave caused air pressure fluctuations strong enough to be measured in Great Britain. Okay. They also
Just press it twice, John.
Huh?
Press the same direction twice.
Okay. Now, the closest we have to the thing is the Chelyabinsk meteor. I don't know if y'all remember that from about 6, 7 years ago, the one that came in Russia. It's February 15th, 2013. Oh, I guess it's more. So 9 years ago. At 3:20 Universal Time, there's a super boloid about 62 foot across. The speed was coming in about 41,000 miles per hour. There you go. The airburst was about 97,000 foot high. The blast yield was about 400 to 500 kilotons of TNT. The light is visible up to 62 miles away. Over 1,500 people were injured, with 7,200 buildings and 6 cities were damaged by it. And windows were blown out. The falling glass were caused most of the injuries. Now they said that that one there, that large portions of it fell in a frozen lake close by there. They've actually managed to fish out some pieces of it now that has come out of that lake. And I don't know if you saw it, there's a lot of things like we saw on the news that time there, that people had the cameras in their cars. You could see it coming across. There's films of the cars showing the windows shattering and all the different damages. We saw a lot of it on there for that one there. Now that was the closest one out in that general area of Russia that has happened. Now the asteroid 2018 LA was found by Carolina Stanford on June 2nd, 2018, which is a little bit more than 7 hours before it entered our atmosphere. It entered the atmosphere near the border of South Africa and Botswana. It was traveling to the east about 17 kilometers per second. And had a really spectacular fireball. Asteroid is about 2 meter diameter boloid. It's very small, and 2 meters. The explosive force was only about 300 to 500 tons of TNT, estimated from a strong infrasound detection. And this is a picture of it, one here that was taken there. That's the boloid coming in. It's at 6:49 local time. So I don't know if you don't remember that one there. That was another close one that we had that it came through. Now, all NEOs, near Earth objects. And we had some December 2015. Congress has directed NASA to find 90% of all NEOs larger than 500 foot size. The JPL has a Center for Near Earth Object Studies. And I read you what one of the gentlemen said about the Tunguska one from it. Over 17,000 near-Earth asteroids and over 100 near-Earth comets have been detected so far. We have potentially hazardous objects, or objects over 500 foot or 140 meters across. There's 1,901 objects have been found. Many current sky surveys discover objects, and many nations are also searching for it. They're trying to get it down as small as they can. They've got about 90% of it done. But the other 10% is getting smaller and smaller, and getting harder and harder now to find it. And I just want to mention that I haven't come across this, but I would say that, in my opinion, a lot of these large surveys that they do that might be able to find some of this stuff here are artificial satellites up in the sky, are probably interfering with some of this here, in my opinion. It's just my opinion, I'm not sure. But I would think that the large sky surveys with all the artificial satellites moving across and taking up things like that would probably interfere with something there. And also, they also understand how these satellites are starting to interfere somewhat with the radio telescope work, which is also some things used to find these objects, because they're bouncing radar off of these, or the high frequencies from radio telescopes, bouncing them off these objects to find them. And we know that these satellites in low Earth orbit are now starting to interfere with radio telescopes. This is just my opinion. Okay, so anyway, the near Earth objects here.
So,
Yes.
your surmise was correct. There was a statement not long ago that I read that it is interfering
Yes.
with satellites.
And just give you an example here. There's the meteor crater in Arizona, viewed from the upper observation deck. I'm sure everyone has probably seen this. It's the Behringer crater out there.
That picture is distorted.
Yeah.
You really
Yeah.
shouldn't use that picture. That's a fisheye and very well.
Right, I agree. It's a distorted view, as you say, Chris. That was the one I had available when I put this program together.
I know, but that gives a very wrong
Yeah,
impression.
it does. It's not that steep and it's not that. It's a Behringer crater. It's known as the meteor crater. It's about 50,000 years old. They said it was a nickel iron meteor of about 160 foot across. Modern estimated speed is only 8 miles per second. Did this? It's estimated to be a 10 megaton blast. It's 3,900 foot diameter, 560 foot deep, and the rim surrounding the crater rises about 148 feet above the plain. Now, Mr. Shoemaker, the Shoemaker Levy, fame for that comment there, he was the one who decided that this was an actual iron meteor crater, not anything else like that. And he spent years to prove it. Found particles of stuff of the the meteorite there. And finally, after years of research and work on it, he finally got people to, yeah, it is one. That's how we now know it is a meteor crater, thanks to Mr. Shoemaker's efforts years ago.
What did they think it was before that?
They thought volcanic or something like this. Maybe like a caldera of a volcano that exploded, and the rest of the land around it eroded it down, giving this caldera of a volcano there. And now, bolides, which are these ones that explode in the air, and all the big ones we see, that you see in the air, with pictures of. These are the events since 1994 to 2013. These are small asteroids that disintegrate in Earth's atmosphere. The daytime ones are the yellow on there, the night times are the blue ones on it. Okay, and then by the size of it, that's the size of the energy in gigajoules of energy. But you can see how they're hitting pretty much all over the planet. And this is at a 9-year period. So, as you can see also the Tunguska one there, out there. You can see the Russia there is a fairly big one there, the daytime one there.
Is this the recently declassified radar data that the U.S. government has released?
No, this was data from about 5 or 6 years ago. It's not the recent stuff.
Okay. I saw an article. There was something that showed up this morning. It looked a lot like that. I was just curious.
And this is declassified here. Okay, what is next after all this? So there's a worldwide concern about Earth being struck by a large object from space. You know, lately, last year or two, we've been hearing about some of these very large ones that are coming in, and inside the orbit of the moon, coming close to Earth, but none of them have been close enough to hit us or even really worry that much about it. So many countries or organizations are searching for any potentially hazardous object. Nations are investigating methods that can be used to move or remove an object that will hit Earth. They talked about everything from sending bombs up to it, missiles up to explode on it, to sending like small rocket motors up to attach, to like land on it, and then fire the motor off where it can shove it a little bit like this. All they need sometimes for something that might potentially hit Earth is just a slight change in its orbital path, and that by the time it gets to Earth, it will be a big enough change so it's going to go past us for no big deal. And then movies notwithstanding, blowing up a large object just creates smaller objects. It can still, the shades of, I believe the movie Armageddon was it, that one, yeah, where they sent nuclear bombs to blow that one up. It just calls smaller ones, and they're all still going to come in. The small ones are there. Now there'll be a lot of them probably burn up the atmosphere, but there's going to be big enough ones where they're going to do damage on it. So don't even think about blowing these up.
Nice wide field.
Huh?
Nice wide field.
Oh yeah, that's my field. It means instead of hitting one little area, it's going to hit all over the place. But anyway, that's what's next on here for this. That's all the program I have on. So, do we have any questions on this right now about Tunguska?
I've been trying to figure out how to word the question, but I'm just saying on composition of all these things. I mean, you know, we have an idea of composition of the meteor crater.
Right.
We have an idea of composition of what caused this to.
No, they said that they talk about they don't.
Because there's nothing they found, but in terms of what breaks up, we have probably a better idea now of the composition of what will break up and cause that versus what won't break up. But I don't see
see, some people are thinking that there's been some things about there was an ice type of asteroid or something like this, but ice just won't do it. It had to be a metal, a heavier metal or some type of other bolloid on it. Now, as I say, there's a Tunguska workshop by NASA applying modern tools to understanding it. And a few things out of it there. So in the background, it says, okay, let me see there. There. Okay. Since, by the way, there was several reliable deaths in nomad camps about 25 kilometers from the impact epicenter there. Okay. Okay, you have one gentleman here who did previous impact models, modeling of it, and he estimated a yield of 3 to 5 megatons, although they're saying now it's more. Okay, some of these people who did this, they utilize data from forestry management sources on the strength of trees and the resistance to uprooting or snapping by wind to estimate that 50% of the tree fall requires a sustained wind speed of 35 to 55 miles per second. Meters, so just
Second meters, not miles.
I'm about to say it.
That's true.
The model fits, different models fit the clustering at around the energy of 10 to 15 meters. Okay. Let me see. For another study, they ran 10 million Tunguska scale simulations to assess what asteroid and entry properties are most likely to produce the observed damage. Just what you asked. It says the blast damage criteria were more likely met by larger energy and sizes of about 20 megatons of weight, 70 to 90 meter in diameter, despite the lower impact frequency relative to smaller impactors. It says also the most likely burst altitude range for producing this blast radii was around 8 to 13 kilometers high, and the entry parameters for the velocity of Nagel were more influential in compositional parameters, in other words, density and strength of it, in determining airburst, altitude, and ground damage. They had another simulation that for the unified treefall map compiled, they showed that the inclusion of the terrain in the simulations increased the maximum overpressure and wind speed by 26% and 21% respectively when compared to flat ground. A lot of the models done they just did for flat ground. In this particular one here, they said this line, they took the terrain itself, the actual elevations of the terrain of this forest there, like that. It says simulations with the terrain closely reproduce the observed north-south symmetry of the butterfly pattern, because the pattern of the way the trees are stacked down is like in the butterfly shape. So the butterfly pattern of forest damage, the maximum ground winds occur in 2 locations, to the north and south of the immediate ground track east of the epicenter. For the 15 meter cases, the maximum winds reach 64 meters per second and diminish to about 40 meters per second near the edge of the observed butterfly region of forest damage. For the 10 megaton cases, the winds were considerably weaker, peaking about 45 meters per second and diminishing about 25 meters per second at the edge of the tree fall. Anyway, they talk about this. Preliminary conclusions were that the details of the tree fall pattern are necessary to constrain the meteoroid properties, and that a 15 megaton air burst with a 11.5 kilometer effective burst height seems to be the least unlikely case of it. Now, there's the most likely case of this particular model. Okay. Now, one guy has done the research on the actual boloids, asteroid, whatever you want to call it there. He says there's sufficient velocity of it. Some hot air from the leading side may be able to penetrate the object, destabilizing it and leading to a breakup faster than calculated, based only on the basis of mechanical and thermal stress. He concludes that this percolation of hot, high-pressure air into the body of the entering meteoroids is a previously unrecognized process that may greatly enhance their fragmentation and dispersion. The phenomenon may explain why the approximately 100-meter diameter Tunguska object disintegrates so completely before reaching the surface, suggesting that the Earth's atmosphere may be a better screen against smaller impacts than previously thought. And you might be able to say something about that, about this air.
Well, again, it depends on what you came in. The batteries were created in solid rock, nickel iron.
Right.
Yeah.
Fragment it, but straight
Yeah.
around.
Right.
You get the composition in the jelly mix, it was a stony iron, and they will tend to fragment more easily. So it depends on, the composition depends a great deal on how it will fragment.
Right, well, this guy said that if it was porous enough
Oh,
to
yeah.
add air, that could explain why there's been no trace, no particles, nothing found.
They found some pretty decent sizes from jelly.
Right, but we're talking about Tunguska, right?
Yeah, I know, I'm just saying, they didn't
Yeah,
find
they,
anything.
oh, so they pulled a fairly large piece out of that lake.
Oh, yeah.
side there.
Yeah, so it may be that it was, like I said, it was more fractions than the rest of the
Now, well, I mentioned on the slides there, it's about the infrasound. It says that the strike was detected by its low frequency infrasound pressure wave observed by the detectors in Russian Siberia and in Europe. And we said that it was actually detected in England. The seismic signal was recorded at Irkutsk, at about 1,000 miles south of the impact. These sources provide independent measures of the energy of the airburst. Now, Peter Brown from the University of Western Ontario, Canada, with his students, presented a paper called Infrasound Detection of Boloids Tunguska Re-Examined. His current summary of the infrasound and seismic data is based primarily on two good quality microbarograph records from that time period. He finds that comparison with nuclear weapon tests are consistent with the Tunguska energy yield substantially less than 30 megatons. The Raleigh waves from seismic acoustic coupled waves detected for the Chernivtsi and Tunguska and analyzed in the same way are consistent with an explosion energy in the order of about 15 megatons. Therefore, the best energy estimate from combined infrasound and seismic data is about 10 to 20 megatons. It's consistent with the most modern modeling of airburst as constrained by the ground data on tree fall and burn distribution. So the equivalent size of the Tunguska meteoroid, assuming similar composition to the 20-meter diameter Chernivtsi active, is roughly 50 to 70 meter size. And the conclusion on this whole NASA thing on there is that they clarify the current status of the airburst modeling and identify the primary sources of uncertainty describing this event. Results from 4 different modern computer codes and modelings were in general agreement. They converged on the most likely, or at least unlikely, as they say, energy for Tunguska in the range of 10 to 20 megatons, and corresponding to a diameter of 50 to 70 meters, if the composition was similar to Chernivtsi as assumed, or a wider range where different compositions and entry velocities were considered. So these results agreed with the recent simulations in Russia, with the conclusions from reanalysis of the seismic infrasound data. However, the energies are significantly higher than those derived by Mark Oslo a decade earlier, which I just mentioned on the beginning of this information here. It also did not account for the suggestion by J. Lawash that a percolation of hot gas through the asteroid during its plunge might accelerate its breakup, which is what we just discussed there. Little modern effort has been applied to simulating the upward plume of material ejected from the explosion. And most of the Tunguska simulations are constrained primarily by the tree fall pattern, without explicit consideration of the data on the burned trees. Not all of them were burned, a lot of them were, but not all of them. And there was none that were just totally burned up. And they're all highly charred and highly burned, but none were just totally destroyed by fire. So the primary uncertainties in these results reflect the limited data on the event. Stress was placed on several presentations on the influence of the force health and topography, which had not been considered in many of the earlier studies. Assumptions about the wind speeds necessary to knock down trees on the very topography of the site that substantially influence the estimates of the energy of the airburst. There are also uncertainties in how an impact airburst of this size couples to the ground or seismic signal or to the atmosphere to create the infrasound signal. It's also noted that most simulations assume a 45-degree entry angle, so it would be valuable to try to determine the parameter independent from the eyewitness observations. That's all we have for the 45-degree angle, is some eyewitnesses, and all this was interviewed 20 years after the event. So the conversion of the information from various models is encouraging. So what the models yield is basically the energy of the explosion, which cannot be translated into its impactor size without assumptions about the density and trajectory. While it's possible to estimate probable values, the uncertainties of impactor sizes and impact frequencies that match Tunguska data are quite large. The addition of better knowledge of the health of the forest, the use of the burn data, an additional study of infrasound and seismic signals should strengthen the models in the future, but are unlikely to greatly improve estimates of impact frequency for those class size events. So basically, they're saying that we have an idea of what it is, but even with the modeling and stuff, we still don't know exactly what it was. It was an airburst, they're pretty sure. They're pretty sure it was a meteorite like this. But what its composition was, they don't know. The size, they don't know what it was. The blast energy, they don't know for sure. And the problem is now this is more than 100 years later. All we're going to have to go by, like for the burn data and different things, are all the pictures that were taken. So,
And the pictures done,
yes.
just sort of aside, back in the 50s, there was some people speculating it was a nuclear fusion reactor inside one of these UFOs that flew. So, I don't know if you went back that far, it came across that article, but I remember reading it many years ago. It was interesting, but not too much credence to it.
No.
Well, that article also contained that they had an eyewitness of the object changed direction before it exploded. I read that thing too. It was funny.
But they did find, they think they found part of the impact though. It's a lake now in that bog. There's a lake that is underneath it.
Yeah, I have read, I don't have any of this information here, but I did a quick search this afternoon, read down the news, and this and they were definitely ruling out the lake was not the aftermath.
Okay.
The lake was already there.
About 2 or 3 months ago.
No, they ruled it out now. The lake is not an impact crater or anything like that. Okay, it's already there at that time.
Well, Barrington Crater, you've been there?
Oh, yeah. I got to walk down in.
Well, yeah, 30 feet tonight. Carol and I went there years ago. I told her she has to see this, and I want to see it too. As we drive into it, it's just a gradual rise. You don't see anything. And she's sitting there about ready to kill me. Where did it take me to? There's nothing here. And then when we got to the point where there's a welcome station and where they charge you,
Yes.
you can't see anything until you pay.
Of course.
And then you walk in, and then she looks at this hole in the ground, and this little mining cabin down at the bottom of it.
Why are you showing me a hole in the ground, huh?
Yeah. Oh no, she got excited when she actually saw it, but she was ready to go home. And at first, she was going to make me turn around and go to Grand Canyon first.
Now, I gotta tell you something here. When I drive out to the Texas Star Party, I take I-20 from Shreveport all the way out to Pecos, Texas. All the way out there to the Midland area, there is a Midland
Yes, it is a
crater.
crater. That's it's an answer.
I have not been to it yet.
I have not been to it, but
I plan on one of these days stopping off.
And it is a real meteor.
It is a real meteorite crater. It's not that big.
No.
But I just want to mention that there is one there on the drive out there.
Yes.
A lot better than what we have in Louisiana. Ours is a swamp.
Okay, we got any questions about Tunguska? Okay, then I guess I'll conclude the program for tonight then.
Can you imagine, just a thought question. Can you imagine if Tunguska had been an incident in around 1965, 68.
Yep.
What the consequences would have been.
Oh, yeah.
There's a people theorize we might have had a nuclear war because of worship right afterwards.
I have it. Okay, we stop live stream yet?
We can just tell the folks good night.
Okay, then that'll be the end of our live stream for tonight, and hopefully we'll have all of our technical difficulties worked out for next month's meeting. Thank you for attending this meeting.